Hi again, time for another probing tutorial. So today we're going to have a look at how to utilise your spindle probe by setting your work offsets, but also take a deeper dive in some of those additional actions you may not have realised are just one click away from inside of Fusion. So are you fed up of scouring through manuals trying to find the correct macros to call? Did you realise that you can do all this from inside of Fusion? Hopefully by the end of this video you'll pick up some helpful tips and get the most out of your spindle probe. So we're going to be making our trusty Autodesk bottle opener today. I've lost count on the amount of these I've had to make now. So we're going to start off with our normal rectangular billet of material. That's going to go into our Lang vise for operation 10. At the end of that, we're going to have something that looks a little bit like this. So we're going to have where we've cold on still on the bottom and then the machine surface on top. We're going to flip that over and put it into our set of soft jaws where we're going to machine the top off that component as well. So again, we've got our parts set up in our Lang vise. Let's hop over into Fusion and see how we're going to program this. Here we have our project. We've got our setups for our soft jaws and then the two setups that make up our part, operation 10 and operation 20. For op 10, it's a nice easy rectangular billet. So first thing I want to do is set up my X and Y datum. So let's go to our probing tab and choose probe WCS. I'm going to select my tool from our cloud library and then just select the top face here. It's guessed that I want to do the probing in the XY rectangle first. But we can do so much more than just set our datum. We've had problems in the past with bar ends being included into our material and not notice. This usually is annoying and results in a scrap part with non-cleanup. But the bigger issue is if we get an oversized billet. This is going to dramatically increase our initial step over on our first pass, and worst case it will snap our tool. So what I'm going to do here is apply a tolerance, and I'm happy for our stock to be 0.5 millimeter larger or smaller, so this is my tolerance. I'm then going to go and turn on the action wrong size. So what this will do is not only set my X and Y datum, but also check the size of my material is within these tolerances. So now on to setting up my Z position. Again, selecting the surface, I now need to just change this to a selection of that Z surface. I can either stick with the default being the center, or I can choose the selected point I clicked on originally. Rather than checking the size here, I need to check the position. If my part is too low, then I'll potentially collide with my jaws. If it's too high, then I have a chance that I may have misloaded the components. Again, I'm happy with 0.5 millimeter in either direction. Let's turn on the out of position action. The order you choose these operations does make a big difference. If you are probing a small surface in Z, then I would always recommend probing X and Y first. That is because you'll probe X and Y and set the datum, and this will then of course affect the position you'll probe in Z, making sure you probe the right position every time. So let's create an NC program and run this on our machine. So let's run our program. But first remember, although we've programmed the WCS in Fusion, we do need to make sure we've set it up roughly correct first before we start. We can't just put the part in and hope we find it. We have got to set that up manually to begin with, but this is brilliant for repeat production. So we're now going to start doing our XY datum. So we're going to probe along the X first. That's perfect. Now we're going to go along our Y axis. So hopefully if our billet's the right size, we're not going to get any alarms on the machine and we'll carry on with our Z. There we go. We've now set our Z and it's checked the position of that as well to make sure that we are in the correct location within 0.5 millimeter. Now onto our cycle. So that's our Op 10 finished. So finished up our Op 10 part now, and we're going to have a look at Operation 20. So we've got our soft jaws here, and I'm going to turn the part over and locate it in these. My datum is going to be the bottom of these soft jaws. Now I'm very confident that that's not going to change from part to part, so I've got no need to probe it. And we also get quite a good location in X and Y, so I don't think that's going to change very much. But we have had a couple of misloads recently making these parts, so I want to try and use our WCS probing to stop that from happening. So when we turn our part over and locate it into our soft jaws, I've only really got the X and Y of this raw block to probe. Now that's not going to be accurate enough for what I want. But what I can do is wait until I machine the top face off the part to then expose that bore. So what I'm going to do is I'm going to machine the top off, expose that bore, come in with my probe then, probe that hole, work out is it in the correct place, refine my datum, and then carry on with the engraving and the chamfering passes. So this is showing that a probe WCS operation doesn't necessarily have to come at the very start, it can come midway through once you've actually exposed additional features to probe. So come on, let's change these vices over and crack on. So what I'm going to do here, I'm going to actually use one of the parts I've made previously. I'm going to clamp that in, and I'm going to set my G55 offset this time to the bottom and to that bore. That's going to give me a really good location to start refining for every part from now on. So while I'm setting this up, why don't we jump back into Fusion and have a look at how we're going to do this in the program. So you can see here for our Op 20, we've got our datum positioned in the bottom of this bore. So what I'm going to do is go into our probing tab, make another probe WCS item, select that bore and apply 0.2 millimeters as the tolerance. Then go over to my Actions tab and apply an out of position action. So like before, this is going to probe the part and then alarm if we are out of position. So again, let's just drag this into the correct location. So I want it just after my facing pass. And I'm going to create an NC program and post-process. So let's run that cycle that we have just posted out from Fusion. So that's our Op 20 now finished. So we've got our completed part that we've dated correctly on both sides. So that was everything happening perfectly. But what happens when either we misload the part or we've got the wrong size? We can start having a look at what happens there now. We've intentionally loaded the wrong size billet into our machine here, and we're going to run that initial program again. So we're now probing along the X direction. And we get a feed hold condition on the machine and an alarm saying out of tolerance. So I'm going to carry on because I want to see how far my Y is wrong as well. And again, we get that out of tolerance condition and the machine's in feed hold. So I definitely don't want to carry on now. So I'm going to hit reset to get out of that program. So there is actually a way of collecting the data from this. And that's something called print results inside of Fusion. That allows us to actually create a file on the machine that records all this data. There's a couple of things you need to set up on the machine to get this to work. That's setting 261. So just hit setting, type in 261 and then the down arrow. That takes you straight there. I can then make sure that that is set to file. And the next one is setting 262. That's the file path. So I'm going to go to list program. I'm going to choose the folder that I want that to go to. I'm going to hit F3, go all the way down to setting 262 dprint, and then hit enter. That's now set that as my dprint location. So let's have a quick look at the file that gets written. So we can now see that we've got the component and the feature, and we've got an out of tolerance alarm here. So our part was 8.7 millimeters shorter in the X, so that would have definitely made a scrap part. And it was 10 millimeters wider in the Y. That would have probably snapped my tool. And a little top tip here is the component number and feature number can be controlled from within Fusion. So the increment component can be selected, and that will increment the component number and reset the feature number back to 0. If you don't select that, the component number will stay as it is and it will increment the feature number. So the way I do this is if I've got 3 or 4 probing operations, I select the first one to increment the components. So thanks very much for watching and see you all again soon.